Here's a riff from In Mazes by the progressive metal band Vola. What patterns can you hear? You may have heard a few different layers. The higher keyboard chords have a steady dotted quarter note rhythm, which grooves against the 4/4 backbeat pattern in the drums. You may even have heard that the guitar and kick drum follow a repeating rhythmic pattern lasting for 9 quarter notes, made up of 14 attacks, which sounds like this.
This stack of patterns is probably familiar if you listen to math metal or math rock. In music theory, we have several terms to describe situations like this, including polymeter, metric dissonance, and metric superimposition. But there is actually one more pattern in this riff which is much harder to hear. The guitar part also follows an independent pitch pattern, which is made up of 13 pitches, one fewer than the number of attacks in its rhythmic pattern. This means that the alignment of the pitch pattern and rhythmic pattern shifts with each repetition, making it harder to hear either pattern.
This short section contains several patterns of different lengths. In this video, we introduce the term polycardinality to cover the whole world of possibilities for playing multiple patterns of different lengths at the same time. To understand the logic behind this strange corner of the musical universe, we'll need to introduce a couple of basic concepts.
Say we have a pattern which consists of a repeating ordered series of elements. This pattern will have a cardinality, how many elements of the pattern need to pass before it repeats. In mazes, the cardinality of the hi-hat and snare backbeat pattern is 4 quarter notes, while the cardinality of the guitar and kick pattern is 9 quarter notes. But in another sense, the guitar and kick pattern has a cardinality of 14 because it has 14 elements. This means that a single pattern has multiple ways of interacting with other patterns.
These patterns can be either superimposed or mapped onto each other. Superimposing a pattern onto another pattern means simply playing them at the same time. This is what happens with the guitar pattern in 9/4 and the drum pattern in 4/4 in mazes. On the other hand, mapping one pattern onto another means using two different patterns to fill in each other's musical dimensions. For example, in mazes, the guitar riff's rhythm is determined by the 14-element kick drum pattern, while its pitch is determined by a different 13-element pitch pattern. The single angular riff that we hear is actually the result of two different patterns in different musical dimensions mapped onto each other.
Whether superimposed or mapped, if the patterns of a polycardinality repeat for long enough, they'll complete a full cycle and their starting points will line back up. In mazes, the 9/4 guitar pattern and the 4/4 drum pattern complete a full cycle after 36 quarter notes. On the other hand, the 13-element pitch pattern and 14-element rhythmic pattern in the melody wouldn't complete a full cycle for 117 quarter notes. And if we wanted a full cycle that included the guitar pattern, the drum pattern, the pitch pattern, and the rhythmic pattern, that would take 468 quarter notes, which would take more than 3 minutes to complete. Understandably, bands often truncate one or more of the patterns in a polycardinality before they complete a full cycle. In mazes, the polycardinality continues for 36 quarter notes, allowing the guitar and drum patterns to complete a full cycle, but prematurely ending the cycle of the pitch and rhythmic patterns.
Let's look at some more examples. Here's a riff from the progressive post-metal band Intronaut's song Killing Birds with Stones. The guitar's rhythmic pattern alternates high notes with lower palm-muted notes. Initially, all of these higher notes are C sharps, an octave above the lower notes. Then, one of the guitars introduces a pitch rhythm polycardinality by mapping a chromatic 3-element pitch pattern onto the 5 high notes of the rhythmic pattern.
This polycardinality is not too difficult to track in real time because both patterns are relatively short. However, polycardinalities are often not easy to hear. A riff from the song Library Subterranean by the experimental metal band Chaodot shows how quickly these patterns can become overwhelmingly difficult to keep track of. In this riff, there's a tricky 22-element rhythmic pattern in 17/8 outlined by the guitars and kick drum. Mapped onto this is a disjunct 5-element pitch pattern in the guitar and a matching 5-element pattern in the drums. Finally, there is also a prominent, steady, timekeeping symbol superimposed over all of this. Fundamentally, the approach is the same. We have a pitch pattern mapped onto a rhythmic pattern. But as the number and length of patterns involved increases, it gets harder to track any individual pattern. The resultant riff can give the impression that it's chaotic or random, even though it's actually meticulously ordered.
Up until now, we've seen polycardinalities that map rhythmic and pitch elements onto each other. But the non-pitched timbre pattern in the drum kit in Library Subterranean shows that other parameters can participate in mapping as well. One other such parameter is text in a vocal part. A straightforward example of a text rhythm polycardinality can be found in the song Spirit of Poison by Car Bomb, which maps the 6 syllables "Don't Contradict Yourself" onto a 10-element rhythmic pattern. Don't contradict yourself, 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 don't contradict yourself. In principle, there's no limit to what musical dimensions might be mapped or superimposed in a polycardinality. And in our experience, when polycardinalities involve dimensions other than rhythm, pitch, or text, they can sound especially disorienting. For example, the opening riff of Car Bomb's song Garucha is based on a 4/4 9-element rhythmic pattern. This pattern on its own is not terribly difficult to grasp. But in Garucha, Car Bomb maps a 2-element articulation pattern that alternates unmuted and palm-muted notes onto this rhythmic pattern, obscuring this more familiar rhythm and resulting in something bouncier and less predictable. An even trickier example can be found in the song Mirror Mirror by the math rock band Palm. Here, the drums play a 3+3+2 tresillo-based rhythm. The rhythmic pattern of the polycardinality uses every other element of the tresillo pattern, starting on the second one, so grouping the 3 and 2, then the 3 and 3, then the 2 and 3. Then the guitar plays an articulation pattern which alternates between starting a chord and ending a chord on each of these note groups.
So they hold a chord for the 3 and 2, then release it and play nothing for the 3 and 3, then hold a chord for the 2 and 3, and then release it and play nothing for the 3 and 2, etc. And on top of this, the guitar also alternates between 2 different chords. So overall, we have a 4-element pitch/articulation pattern in the guitars mapped onto the 3-element uneven rhythmic structure of the drums. Because the space between chord attacks ends up being 11, 10, and 11/16 notes, this section may even give the impression of slightly wonky whole note triplets rather than the intricate additive structure that the band feels.
Sometimes it can be more challenging to formally describe the structure of a polycardinality than it is to intuit what is going on. Here's a riff from the song Afghanistan by the math rock band Botch. What patterns can you hear? You may have noticed the 5/8 guitar pattern superimposed on the 4/4 drum pattern and the 16 quarter note bass pattern, a relatively tame polycardinality compared to some of the other examples we've looked at. You may also have heard how the guitar cycles between 3 pitches.
But it's not obvious how we should define this pattern. We could say that the rhythmic pattern has tied notes, or that there's a meta pattern with note repetition, or simply that it's a long 9-pitch pattern. It's challenging to decide which description is most useful. This is an example where the pattern is easy to follow, but the rules behind it are a little harder to pin down. This is also one of the few examples we've played that completes a full cycle. It takes 60 measures, almost 2 full minutes, for all these patterns to realign at the same place at the same time.
Polycardinalities create auditory puzzles. When I talked to Carbomb's guitarist Greg Kubacki, he compared them to encryption. You can see what you mean about it, like, if you look at it in the right way, it's not that complicated.
Right, but the whole thing is like, we know what it is. But, like, we're curious to see, like, what does it sound like from people who don't know what it is. And we want to keep it that way. It's almost like a hash, like, do you know, like, computer science at all? Do you know about, like, encryption, like how that works? You take, like, a really large number and you multiply it by another really large number.
One
if
way
you know
functions.
the 2 numbers, it's like, oh, of course that's what it is. But if you don't know, you just see a giant number, you're like,
oh, that's so cool. From the compositional side, polycardinalities allow bands to create dazzlingly complex sections out of a few relatively simple components. Many listeners revel in the resulting feeling of overwhelming, opaque unpredictability, but for others, polycardinalities are challenges, musical puzzles just waiting to be decrypted.